Hey guys, today we're going to start a lesson on Unit 6, which is all about probability. And today we're going to talk about theoretical probability and experimental probability. To find theoretical probability, we divide the number of favorable outcomes by the total possible outcomes. For experimental probability, it's much the same. We divide the number of times an event occurs over the total number of trials. In this unit, you're also going to need to know the definition of a prime number. Prime numbers have factors of only 1 and itself, and the lowest prime number is 2. We're also going to talk about finding the probability of A or B. So when we do that, we find the probability of A plus the probability of B, and we subtract anywhere that both of those could occur at the same time. We'll talk about that a little bit more in a minute. Let's look at example number 1. If we're rolling a 6-sided die, our possibilities on the roll are 1, 2, 3, 4, 5, and 6. So there are 6 possible outcomes. If we want to know the probability of rolling a 1, there's only one way I can roll a 1 out of 6 possible outcomes. So the probability of rolling a 1 is 1/6. The probability of rolling a 2 or a 3, well, there's only one way I can roll a 2, and there's one way I can roll a 3. So total, there are 2 ways I could roll a 2 or a 3. And possible outcomes, there are still 6 possible outcomes. So 2/6 reduces to 1/3. So when we're thinking about rolling a 2 or a 3, we're adding those probabilities. We don't have to subtract anything because when we roll a dice, there's no way I can roll a 2 and a 3 at the same time. The probability of less than 4, that means that we could roll a 1, a 2, or a 3 and be less than 4. So there are 3 possible outcomes out of a total of 6 outcomes, and that reduces to 1/2. For the next one, the probability of rolling a factor of 12. So when we roll a die, our choices are a 1, 2, 3, 4, 5, or 6. So we want to know which ones of those are actually factors of 12. So 1 is a factor of 12, 2, 3, 4, and 6. All those numbers will divide into 12, so those are factors of 12. So we have 5 possible outcomes over a total of 6. So that probability would be 5/6. For the next one, the probability of rolling a prime number or a divisor of 12. So again, here's our sample space. These are all our possible things that we could roll. Prime numbers. So our prime numbers are 2, 3, and 5. Our divisors of 12, 1, 2, 3, 4, and 6. So when I think about all the numbers that are prime or a divisor of 12, I'm looking at all possible outcomes. So I have 6 possibilities over a total of 6 possible outcomes. So that equals a probability of 1. So your probabilities, the lowest a probability could be is 0. The highest a probability could be is 1. So that event is going to occur. All right, let's look at example number 2. Example number 2, a grocery store recently sold 3 cartons of lemon yogurt and 9 other cartons of yogurt. What's the experimental probability that the next carton of yogurt sold will be lemon? So we want to think about how many were lemon. So we have 3 that were lemon out of the total number of trials. So 3 were lemon, 9 were other cartons of yogurt. So we need to add those together to get the total number of trials. So we get a fraction that's 3/12, and we need to reduce 3/12 to 1/4. For example number 3, you spin the spinner 1 time. What's the probability that you land on an odd number or a divisor of 16? So the chances of me landing on an odd number, so my options are a 1, a 2, a 3, and a 4. So my odd numbers are 1 and 3. Divisors of 16, those are numbers that actually divide into 16. So 1 divides into 16, 2 divides into 16, and 4 divides into 16. So when I look at my possibilities, I have all possibilities. So that means I have 4 possible chances, and I have 4 total spins, or 4 total numbers I could land on. When I reduce that, that equals 1. But my directions tell me to write that as a percentage. So if I want to take this probability and make it a percentage, I'm going to multiply that by 100, or I'm going to move my decimal 2 places to my right to make it a percent. So that's the same thing as 100%. So if I spin that spinner, I either have to land on something odd or something that is a divisor of 16 every time. All right, last example, number 4. Camille's mother recorded what color shirt Camille wore on each day recently. What's the experimental probability that Camille will wear a black shirt tomorrow? So we want the number of black shirts she's worn recently. So she's worn a black shirt 6 times recently. Out of a total, if we take these and add them all up, we get a total of 15 possible choices. So 6 out of 15. And we need to reduce that fraction. We can reduce by 3. So that's going to give us a fraction of 2/5. So the probability of her wearing a black shirt is 2/5. I hope this has helped explain a little bit to you about theoretical and experimental probability. So you'll have some examples to try. If you have any trouble, please email me and I'll be glad to help you.